Okay, so in question number 5, it says, in cats, short hair is dominant over long hair. It says in Angora, which is long-haired male, the only way you're going to get long hair is 2 small s's, since it's recessive, is mated with a short hair female. Okay, if she's got short hair, she has to have a capital S, but it doesn't tell us how she's short. So it says she produces a litter of 8 kittens, 6 of which are short hair and 2 of which are Angora. Okay, so the only way she can have a baby that's Angora is if she's small. If she's a heterozygote, she has a capital and a lowercase. What was the expected ratio from this mating? So here we have this, 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 this. The expected ratio would have been 2 to 2, so 50-50. If these same 2 cats, when mated, produced 50 kittens in successive litters, how would the expected ratio be affected? Well, just based on the fact that they had 8 kittens and 6 were short-haired and 2 were long-haired, that doesn't match this distribution. That's a 3-to-1. So I would say that the way it would increase, or it would show that the successive ratio would begin to increase. Like it wouldn't be 50-50. We would see more of a 75-25 split the more babies that she had. Because there's a 50-50 chance that she's going to have, for, remember, this is not if she has 4 kids, 2 will be this and 2 will be that. This is for 1 kid, there's a 50% chance it'll be short hair, a 50% chance it'll be long hair. So she had all these 8 kittens. It looks like the ratio here is 3-to-1, so it's going to be more of a, we're going to have 75% long hair versus 25% short hair. Okay, number 6 says in Holstein cattle, black and white cattle, the solid coat color is dominant over spotted coat color. Give the genotypes of the parent cattle and complete the Punnett squares for each of the following. So A says, excuse me, that you're crossing 2 spotted parents. The only way you could have 2 spotted parents, because solid is dominant, the only way you could have 2 spotted parents is if you had small. So my parents are here, parent genotypes, and then my offspring would all be spotted. Okay, B says I have a homozygous solid. So that means 2 capital letters crossed with a spotted. So again, this is my P, these F1. So here I have, if we have a solid and mix the solid with the spotted, all of our kids will be solids. C says heterozygote solid crossed with a spotted. Heterozygote means they have 1 capital, 1 lowercase, crossed with a solid. So here are my parents, my offspring. So my kids would be have a 50% chance of being solid, 50% chance of being spotted. Last example says heterozygote solid is crossed with a heterozygote solid. So heterozygote means 1 of each. So in that case, if we're going just on phenotypes alone, this is solid, solid, solid. This one's spotted. If we're going on genotypes, I have 1 homozygous solid, 1 homozygous spotted, and 2 heterozygote solids. Okay. This next one says, suppose a young lady comes to your advice in your capacity as a marriage counselor. She tells you that her brother has hemophilia, but both of her parents are normal. She wishes to marry a normal man that has no history of hemophilia in his family and wants to know the probability of her children having this disease. Okay, so when you have hemophilia, you do a cross with hemophilia. This is a sex-linked condition, and you have to have a small letter if you have it. So when you have a sex-linked condition, you use the sex chromosomes, but then you put the letters of that condition on as superscripts. So if you're normal, you have a capital letter, all right, because normal is dominant over being sick, but it's telling you her brother has hemophilia. Both of her parents were normal. The only way her brother can have hemophilia is if both of her parents were a carrier, which means that she is also a carrier. So this is her genotype. It says, and she wishes to marry a man that has no history of hemophilia. And so remember, a male has a Y chromosome. And if he doesn't have a history of hemophilia, he has a capital H. So you mix these just like you would a normal Punnett square. So here I have a normal baby. Here I have a normal baby, but a carrier for hemophilia. Here I have a normal baby. And here I have a baby with hemophilia. These two are girls because they have two X's. These two are boys because they both have a Y. This baby has hemophilia. I would tell her that if she has a boy, there's a 50% chance that he would have hemophilia. That would be my advice to her if she came to me talking about family planning. Okay. For this number 8, it says an Andalusian fowl, black is incompletely dominant over white. So in this case, to be black is this. To be white, but if you have both, you are blue. So that's what it means by incompletely dominant. So heterozygotes are blue. What offspring will a blue fowl have if bred to birds in the following plumage? So we have to do 3 problems. So here is a blue one. To cross it with a black, it would be that. So it would be 50% black, 50% blue. If I cross the blue with the blue, I would have 25% black, 50% blue, and 25% white. If I did the last one, it says cross the blue with the white, I would get 50% blue, 50% white. Okay, last one. And I'm gonna have to start another video.